Hello guys, welcome back to IT Classroom. I hope you are doing well. Today we'll be solving AS level Physics 9702 Paper 1 Variant 2 from Feb March 2025. This is a 1 hour 15-minute paper. It has 40 questions with each question being a 1 mark. Hence this paper has 40 marks. And this is one of the 3 papers for your AS level Physics and one of the 5 papers for your A level Physics. And this most of the people as opinion say that this might be the hardest of the other of the 3 papers that you have in AS. So I hope that in this video you will gain in-depth explanation of all the questions and answer your doubts and score well in the upcoming AS Physics exam on 5th of June. Alright, let's start. If you're new to this channel, do not forget to like, share and subscribe for more helpful content for IGCSE and AS level. Alright, let's start. So there's a data sheet on the first page of the exam which has some constants as well as some formulas, and these will be very helpful for you when you're solving the paper. Alright, so the first question here is, which quantity is a scalar quantity? Now remember that a scalar quantity is basically a quantity which only has a magnitude and does not have a direction. Force is not scalar because it does have a direction. Momentum also, it is in a particular direction. That means if you're towards the right is positive, towards the left would be negative. Velocity is again a vector quantity because velocity is basically your speed in a given direction or displacement per unit time. But displacement is a vector quantity, so therefore velocity is also a vector quantity. Work done, on the other hand, is basically a scalar quantity because work done is essentially energy transferred. So when you have energy is obviously a scalar quantity because it cannot be negative or it does not have any relation with the direction. All right. Now the next question: what is the effect of a systematic error on the measurement of a physical quantity? Now, what does a systematic error mean? A systematic error is basically an error which will bias all the measurements or the readings in the same direction. For example, you have a zero error on your instrument, or you have, let's say, any other type of error which will appear the same in all of the readings. So now, when you have a systematic error, what happens is that it will result in your measured value being different from your correct value. The option is D. The option C is wrong because it says it results in repeated measurements having different values from each other. That's not correct because the readings normally would be different from each other, and that could also be the result of, let's say, if you're taking the same measurement multiple times, it could be different because of other types of error, not systematic error, random errors, that is. It limits the range of values obtained in repeated measurements. It does not limit the range of values. It will basically make it either it'll increase all of the readings or it'll decrease all the readings. It limits the precision. No, it does not limit the precision. The precision would still remain the same because they all would either be positive or towards the negative. So the precision remains the same. Okay. Now question number 3. A car is accelerated by a constant resultant force of 300 newtons for 5 seconds. The variation with time of the velocity of the car in centimeters per second of the car is shown. What is the mass of the car? So what they say is that there's a car and we have applied a constant force of 300 newtons on the car for 5 seconds. The variation of the velocity in centimeters per second raised to -1. It's on meters per second, which is a usual unit. What is the mass of the car? Now we know the formula is that force into the time gives you the impulse, right? Force into time is impulse, which can be written as force into the time is equivalent of the change in the momentum. Now what is the change in the momentum equal to? It's basically mass into the change in the velocity. Force into the time is basically equivalent of the mass into delta V, right? Now the force is 300 newtons. The time that's applied for is 5 seconds. The mass of the car is something that's unknown. The velocity is basically 150 minus 30. Now remember that 150 minus 30, both of these values are given in centimeters per second raised to -1. But I cannot have my values in centimeters per second because the ideal unit is meters. So what I do is I will convert both of these to meters. 300 into 5 is equivalent of m. 150 divided by 100 would be 1.5. 30 is basically divided by 100 would be 0.3. So in order to find m now, what I need to do is 1500 over 1.5 minus 1.3, that's 1.2. Use a calculator. 1500 divided by 1.2, that would give you 1250 kg, which can be rounded off to 1300 kg. So the answer for the first three questions are D, D, and C. Question number 4. An aircraft which is initially stationary on a runway takes off with a speed of 85 kilometers per hour in a distance of no more than 1.20 kilometers. What is the constant acceleration which is necessary for the aircraft? Now, obviously, this is a question where you require the use of SUVAT, or basically the kinematic equations. So whenever you have such type of question, just write it down this way, SUVAT. Okay, now what's the distance I have? It's 1.2 kilometers, which is 1,200 meters. The initial speed is 0. The final speed is 85 kilometers per hour. 85 kilometers per hour. And the acceleration is what you have to find. Obviously, we can use the formula that v square minus u square is 2as. Since u square is not given to us, I mean it's basically 0, v square is equivalent of 2as. Now remember, 85 kilometers per hour, if you want to write in meters per second, it's 85 kilometers per 1 hour. So 85,000 meters. 1 hour basically have 60 minutes, and 60 minutes have 60 seconds. So it's essentially 85,000 divided by 3,600. 85,000 divided by 3,600 would be, wait, yeah. So that will give me the value of the speed as 425 over 18. So my v square is basically 425 over 18, the whole square, is equivalent of 2 times the acceleration into the distance, which is again 1,200. Now when I do 425 over 18, the whole square, divided by 2 times 1200, my answer is 0.23. The option would be first one, which is A. So the answer is A, 4A. Again, I reuse the formulas, and I use v square minus u square is 2as, u square is 0. So v square can be directly equated to 2as. I found the value of v in meters per second. All right, I mean from kilometers per hour to meters per second, and then I just substituted it. I hope this is clear. Now, question number 5. An object is fired upwards from the horizontal ground. The object has an initial velocity of 20 meters per second at an angle of 45 degrees to the horizontal. The air resistance is negligible. Which statement describes the speed of the object after it is fired until immediately before it reaches the ground again? So basically, you're firing an object upwards from the horizontal ground. The initial velocity is 20 and the angle is 45. So for example, it would be somewhat like this. You're firing it upwards at an angle of 45 degrees. This is the horizontal, sorry. This is the horizontal. So about an angle 45, you're firing it upwards, let's say. And then it will be somewhat like this, a projectile, and come back down here. So which statement is correct? Its speed decreases to a value which is greater than 0, and then it again increases to 20 meters per second. Its speed decreases. Okay, now I would say that the answer that is correct is actually A. Let me explain you why. Now we know that in a projectile motion, any object in projectile motion basically has two corresponding units. There is a horizontal unit, for example, this was the speed, so there would be a horizontal component of it and there would be a vertical component of it. The horizontal component never changes. Why? Because there's no forces that are acting in the horizontal component. So when it reaches the top, that is the peak point of the projectile motion, the horizontal component, it would not be 0. It would be something which is which is unchanged. Whereas the vertical one becomes 0. So the speed never actually will become 0 because the horizontal component is never 0. So the speed, and as it moves up, the speed decreases because the value of the vertical component will decrease. So the speed will decrease to a value that is greater than 0, and then it will increase to 20 meters per second, because again the law of conservation of energy, since the air is negligible, when it moves from the ground to up, it gains gravitational potential, and when it goes back down, all of that energy will be converted back to kinetic energy. So therefore the answer is A. Its speed, if you see option B, it says the speed decreases to a value which is greater than 0, but then it increases to a value greater than 20 meters per second. That means that the final energy is greater than the initial energy, which is not possible because there is no form of other acceleration. So this is not possible. Its speed decreases to 0. I have already explained why the speed cannot decrease to 0, because at the top the horizontal component velocity is still there, so the speed cannot be 0. Therefore we can disqualify options C and D, and option A would be the correct, where the speed decreases to a value that is greater than 0, and then it will increase back to 20 meters per second when it falls back to the ground. Question number 6. What is the statement of the principle of conservation of momentum for a system? So the principle of conservation of momentum is that in a closed or an isolated system where there are no forces acting, the total momentum before the collision is equal to the total momentum after the collision, or the sum of the momentum in that system, it will remain constant. So for this, I can see that the C part, which is the total momentum, is conserved provided that no external forces act. Okay. If you see option A, it says that the total momentum and total kinetic energy are always conserved. In inelastic collisions, the kinetic energy is not conserved. So option A is wrong. The total momentum is conserved only in elastic collisions. No, in both elastic and inelastic collisions, total momentum will be conserved. The total momentum of each object in the system is the product of the mass and the velocity. Well, this is correct, but again, this is not the principle of conservation of momentum. That is just more like a formula to calculate the momentum. And we move on to question number 7. Question number 6 is C, question number 7. So here what it says that objects P and Q, they're forming an isolated system. Object P has a mass of 6 kg and a velocity of 3 meters per second, whereas object Q has a mass of 2 kg and is moving at 4.2 meters per second at an angle of 35 degrees to the path of P. P and Q, they collide and they stick together. What is the magnitude of the component of the final momentum of the combined objects in the direction of P? So we can basically find the momentum of P to this direction subtracted with the momentum of Q to this direction to get the final momentum to the direction of P, which is basically towards the right. So what to do the momentum of P? The momentum of P is basically, since momentum is given by mass into velocity, the momentum would be 6 into 3. Now see, the momentum of Q, the velocity is given at an angle. So if you want to find the horizontal one, we'll have to do 4.2 into cos 35. Easy trick to remember, the one that's near to the angle would be cos 35, whereas the one that's far away from the angle would be sin 35. Minus, it has a mass of 2 kg into 4.2 cos 35. Okay, to get the final momentum, 6 into 3 minus 2 into 4.2 cos of 35. When I do this in my calculator, my answer is 11. Okay, so therefore the answer for 7 would be B, which is 11 kg meters per second raised to negative 1. Not hard, it's basically the momentum by an opposite direction, so just subtract them to get the final momentum. But make sure of the angle that you have over here. An astronaut of mass m is in a spacecraft experiences a gravitational force F is equal to mg when he's stationary on the launch pad. So when he's stationary, he's experiencing the force of F, which is equal to m times g. What is the gravitational force on the astronaut when the spacecraft is launched vertically upwards with acceleration of 0.2 g? Now, this question is basically a bit of understanding. There's no calculation that's required over here. You see that if you're stationary in the gravitational field or you are in motion, the gravitational force that's acting on you, it will always remain the same. So whether it's stationary on the launch pad or in a spacecraft which is being launched vertically, the gravitational force acting on him will remain the same. And we can see that the gravitational force is mg. So when he's basically in the aircraft and launching, it will also be mg. The gravitational force acting does not change. Okay, now we'll go to question number 9. The diagram shows a child of mass 20 kg and a child of mass 15 kg. They are seated on a uniform plank. The plank has a mass of 7 kg and has a pivot at its midpoint. The plank is horizontal and at equilibrium. Which statement about the weight of the plank is correct? So the child that is 15 kg is sitting a bit more farther than the child of the 20 kg when you compare to the pivot. That means we can say the momentum would be the same. So basically the momentum provided by the child of 20 kg, I mean the moment, sorry, not the momentum. The moment provided by the child of 20 kg, since the distance is actually small, 20 into this distance should be equal to 15 into this distance, which is rather a large distance. So that means that for these both the momentum is the same. So we can say that the moment, the basically the weight of the plank, it will act over here, exactly at the pivot. Since the distance between the point where the weight acts and the pivot is zero, the moment by the weight is actually zero. So therefore, the weight of the plank can be considered to act at its midpoint. Had it caused any kind of moment, the plank would not be horizontal and in equilibrium. Okay, so that's why we can ignore the other options. On question number 4, it says that the weight of the plank equals to the force on the plank from the pivot. No, that's wrong because the weight of the plank would be acting downwards and there are other forces as well. For example, there would be a force from the child and there would be a force from the child. So the force from the pivot on the rod would actually be much more higher because it has to equal all of the three forces since it's again in equilibrium. Okay, I hope this is clear. I'll move to question number 10. The answer for question number 9 is A. Now, an object is fully submerged in a liquid. The student determines the upthrust acting on the object divided by the weight of the object. What single change would double the value of this ratio? Now let's understand what is upthrust. Upthrust is basically a force that is acting on an object that has been submerged in a fluid due to the difference of pressures in the body. And the formula for upthrust is rho g into delta v, where rho is the density of the liquid, g is the value of acceleration of free fall, and delta v refers to the volume of the object that has been immersed in the liquid, divided by the weight of the object. The weight of the object is given by the mass of the object into the value of g. What would double? Now it says that use a different liquid that has twice its density and the same volume of the original liquid. So obviously this is pretty clear that if I change the density and if I multiply this by 2 and if I keep the volume same, that means I'm just changing the density, this would multiply by 2, g remains the same, the space occupied by that object in the liquid again remains the same, the weight of the object is the same, so obviously the value of the upthrust will be multiplied by 2. Okay, so that's why option A is correct. If you see option B, it says that use a different object that is half the volume. If you half the volume, your G value, I mean your upthrust will be half because this value will be halved and the same density. So no, this is not possible. Use a different object that has twice the density and the same volume as the original object. If you have the twice the density does not take into play the matter. The matter is not about density. It's about your volume of the object. Use a different object that has twice the volume and the same density as the original object. Okay, why is this? Okay, if you basically have twice the density, but if you have twice the volume but same density, then the mass would then decrease because density is given by is basically equivalent of mass over volume. So if you multiply the volume by 2, if the density is same, so that would mean that the mass has also been multiplied by 2. Okay, so if you're multiplying the mass by 2, again the upthrust would decrease because mass is over here. So option D is not correct. Again, if you look at option C, it says that use a different object that has twice the density. If you multiply the density by the 2, if you keep the volume same, the mass will also multiply by 2. And if the mass multiplies by 2, the upthrust would rather decrease by 2. So that's why the option C is also not correct. It says that you apply a simple formula and you actually start understanding what would make a change and what not. And if it is making a change, then what would be the corresponding magnitude of the change? Question number 11. A sharp sign which weighs 75 newtons hangs from a frame that has been attached to a vertical wall. The frame consists of a horizontal rod XY and a rod YZ that is at an angle of 30 degrees to the horizontal. The rod XY is attached to the wall by a hinge at X and has a length of 0.5 meters. Assume that the weights of the rods are negligible. What is the horizontal force that is exerted by the wall on the rod XY? So basically for this rod XY there are two forces acting. There is the weight of the sign which is over here and there's a tension force which is basically holding it. Now this tension force, it would have two components. There would be this one which is T sine theta, sine into 30, and there would be this force which is T cos 30. Our main aim is to find T sine 30 so that we can find T cos 30 because T cos 30 is the force that is acting from the rod to the wall, which would be the same as from the wall on the rod, applying Newton's third law. Okay, now what's the moment caused by the sign on the wall on the rod? That will be 0.50 into 75. When we do 0.5 into 75, that is 37.5. So that's the clockwise. The anti-clockwise, if you want to do the same, 37.5 divided by sine 30, sine 30. Okay, I'll show you why this might not be clear. What I want is 37.5 is equivalent of 0.5 into t sine 30, t sine 30. Okay, because t sine 30 is the force and 0.5 is the distance. So t sine 30 would essentially be 37.5 divided by 0.5. So if you want to find the value of t, it will be 37.5 divided by 0.5 sine 30. 37.5 divided by 0.5 sine 30. That gives me 150. Now 150 is the value of t. If I want to find the horizontal component, I'll have to multiply it with cos 30. That gives me 130 newtons. So the answer is 11C, which is 130 newtons. Question number 12. A student takes measurements to calculate the density of the liquid in a beaker. The height of the liquid in the beaker is 0.20 meters. The internal diameter is 0.05 meters with an uncertainty of 3%, and the height has an uncertainty of 2%. The mass of the liquid is 0.336 and with the uncertainty of 10%. What is the percentage uncertainty in the density? Now, what is density? Density is basically your mass divided by volume. Now, since it's division, we can add up the percentage uncertainties. What is the percentage uncertainty in the mass? It's 10%. So the minimum value has to be 10%. We cannot have anything below 10%. Now, volume is given by basically the surface area into the height. So the height has a percentage uncertainty of 2%, so I'll be adding the 2%. Whereas if you see the internal diameter, it has a percentage uncertainty of 3%. So when you find the radius, obviously that will also have a percentage uncertainty of 3%. And when you find pi r square, which will be the area, we are basically going to do the r square, right? So when we raise something to 2, we'll have to multiply the percentage uncertainty by 2 as well. That will make it 6%. 2 into 3. So when you add up all of this, 12, 12 plus 2, 6 is 8. 10 plus 2 plus 6. That gives you 18. Okay, so the answer is 12, that is 18. 10 for the mass, 2 for the height, and 2 into 3 for the internal diameter, because we are raising the diameter value to 2 to find the area. So therefore the answer for 12 is D. Now question number 13. The diagram shows a uniform plank XY of length 4 meters and a weight of 300 newtons. It's a uniform plank, so that means that the weight acts at a distance of, let's say, 2 meters, and how much? 300 newtons. The plank rests on fixed supports at its ends X, Y, and Z. I mean X and Y. A child of 600 newtons stands at different positions of the plank. The support at end X exerts a force F vertically upwards on the plank. What is the magnitude of the force F when a child stands at X and when a child stands at Y? So basically, when a child stands at X, he will be over here. He will be exerting a downward force, right? So his force downward is 600 newtons. So what is the basically the clockwise momentum? It is 600 newtons at a distance of 4 meters and 300 newtons due to the weight at a distance of 2 meters. So 600 into 4, 600 into 4 plus 300 into 2. That gives you 3000 newtons. So that 3000 newtons is the clockwise. The anti-clockwise moment should also be the same. The anti-clockwise upward over here. If you want to find upward, 3000 will equal to, let's say, x value into the distance, that is 4. So the x value will be 3000 divided by 4, which is 750 newtons. So when the child is at x, the force will be 750, which has to be C or D. So A and B are disqualified. Now once we see when the child is at y, okay, the child is over here. So that means the child weight does not have any momentum right at this point, any moment at this point. So the only force that's acting in the clockwise direction is the weight, which is 300 into 2. that is 600. So with that 600 force, what you want to do is 600 divided by 4, which will be 150, right? So that will be the force on the other end. So that's why the answer should be 13D. I hope this is clear as well. Now we'll move on to question number 14. Which relationship is used in the derivation of the equation shown below? Power is force into velocity. Now we know that power is basically given by work done over the time taken. And work done is basically force into the displacement in the direction of the force divided by the time taken. But I know that displacement over time is basically velocity. So I can say power is equivalent of the force into velocity. So what derivation have I used here? I've replaced the displacement over time with velocity. So therefore, this should be the first one, which is displacement equals to velocity into time. These derivations are very important. Question number 14a, then question number 15. A block is released from the top from the rest at top of the slope, inclined at an angle to the horizontal. The slope has a length L as shown in the diagram. There are no resistive forces that are acting on the block. What is the speed of the block at the end of the slope? So basically, the first thing that I'm surprised over here is that there is no mass given in this question. So probably, let's say the mass is 1, or you're not considering the mass in any situation. We'll apply Suvat over here again, because why not? So if you apply Suvat, you know that the S value is L, U is 0, V is something that we don't know, the acceleration. Now ideally, basically the acceleration would be the weight of the object, which would be prepared over here. But because this object is accelerating on this side, it would be the weight of the object into cos theta. Now again, I said that the weight is, let's say, let it be 1. So we're just going to put it as cos theta. I mean, normally it would be the mass of the object into the value of g, but let's say the mass is 1, so let it be g cos theta, parallel to the slope. Okay, so acceleration is g cos theta, whereas g value is 9.8. So what I need to find is that speed, that is v. Okay, so v square minus u square is 2as. V square is basically 2as because u square is 0. So v will be the root of 2as. So if I know what is 2 into 9.81, that will give me 19.62. 19.62, sorry, what's the value of a? Okay, 19.62 into, it will be the cos theta into L, because that's S. Now I see that this is not an option, but 19.62, if you want to remove it, you can just do 19.62 root, which is 4.429. So it will be 4.43 with L cos theta being in the square root bracket. And that's why the answer is 15B. Again, to make myself clear, V square minus, first of all, we see that the distance it has to cover is L. Initial speed is 0. V is something that you have to find. The acceleration is, normally it would be mg, where if you're taking m as 1, it would just be g. But if you want to find the one that's parallel to the slope, it would be g into cos theta. Okay, g into cos theta. Oh, my bad, sorry, so sorry. The one that's parallel to the slope is always given by g into sine theta. That's why I was confused that why do we actually have this. Sorry for that. This is supposed to be g into sine theta. So when we put it over here as well, this would be g sine theta. So when you put it here as well, this thing, it would be g sine theta, not cos theta. The cos theta is actually this one. If you want to find like this, the one that's perpendicular to this would be g cos theta, and this one would be g sine theta. So we applied the formula. Again, S is L, U is 0, acceleration is g sine theta. V square minus u square is 2as, so v square is equal to 2as. V will be the square root of 2as. So 2a is 19.62 into the acceleration value, which is sine theta, g sine theta. We have already multiplied g, so it's just sine theta, into s value, that is L. Now, because I don't see the option, I will just take 19.62 outside by square rooting it. That will give me 4.43, and L sine theta remains inside. I hope that is clear. 15b. Now question number 16. A skateboarder and her skateboard have a total mass of 70 kg. She pushes on the ground with her foot to create a forward force of 25 newtons on herself and the skateboard as shown. So when she's pushing herself, she's getting a force of 25 newtons in this direction. The skateboarder then travel a distance of 0.50 meters before the skateboard lifts her foot from the ground. What is the force work done by F on the skateboard? Now this is pretty easy because again, as I said, work done is the force into the displacement direction of the force. The force that you applied is 25 newtons. The displacement is 0.50. So 25 into 0.50 gives me 12.5, which we can say as 13 joules because it's work done. So the answer for question number 16 is A. Question number 17. A turbine at a hydroelectric power station is situated at a vertical distance of 30 meters below the level of the surface of a large lake. The water passes through the turbine at a rate of 340 meter cube of water per minute. The overall efficiency of the turbine and the generator system is 90%. That means the output power is 90% of the input power. The density of the water is given as 1000 kg meter cube. What is a useful output power? If I want to find the useful power output, if the efficiency is given, I have to find the input power first. The input power, because the water is just being stored, it would obviously just have energy as the gravitational potential energy, which is given by mgh. Obviously, this will be converted to kinetic energy, but I can just assume it's mgh, basically gravitational potential, because that same energy is going to be converted to kinetic. Now, what's the mass of the water that's passing? I don't know the mass, but I know the density and the volume. Since density is equivalent to the mass divided by volume, I can say that the mass of the water is density into volume. So it's 1000 into 340, and that's the mass. The value of G is 9.81, and it is 30 meters below the surface. So that means ideally it has 30 meters. And that is per minute. So if I divide this by 60, I would get per second, which is essentially the power. 1000 into 340 into 9.81 into 30 divided by 60 gives me 1667700. That's the input power. Okay, now if I want to find the output power, I have to find 90% of this. That gives me 1500930. You can see that all the values are given in megawatts, 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 and megawatts. So just divide the final answer by 10 raised to 6. That gives me 1.5. So the answer should be 17B, that is 1.5. All right, now let's move on to the next question. A projectile is launched at 45 degrees to the horizontal with the initial kinetic energy of E. Assuming air resistance to be negligible, what will be the kinetic energy of the projectile when it reaches its highest point? All right, so basically, kinetic energy is calculated with the velocity. And okay, now for these types of questions, if you're not sure about the calculation, you can just assume up some constants and then you can guess it out. So for example, let's say the projectile, it has a mass of, the mass is 10 kg. And the initial speed is also 10. So the velocity initial is 10. So what's the kinetic energy initial? Half into 10 into 10 squared. 10 squared is 100, into a 10 would be 1000, into 10 squared into 10 into 0.5. That gives me 500. Okay. Now, when you reach at the top of the point, your vertical component becomes 0. So at that point, your only speed will be because of your horizontal component, right? Your vertical component is 0. So what will I do? I will basically find out the horizontal component and then I will calculate the kinetic energy. So the kinetic energy will be given by half into the mass, which is 10 kg, the velocity. Now, for example, let's say that you are at 10, this is your velocity at 10, and this is your theta value, which is 45. So the horizontal one would be 10 cos 45. So when you reach at the top, this 10 cos 45 would remain the same, whereas this value would be 0 because you are at the top, so it'll be stationary. So 10 cos 45, and obviously we'll square this as well. Now let's find it. Half into 10 into 10 cos 45 the whole square. This gives me 215, and initially it was 500. So I can see that it has basically halved. So the correct answer would be 18A. You see that this makes the process much more simpler than making up some constants and stuff. I could do that, but it makes much more harder to explain it that way. And I personally prefer using this method for any of such calculations. It's pretty simple and easy to use. A wire is extended by a tensile force so that its deformation is elastic. What is meant by elastic deformation? So basically, elastic deformation is the deformation in which the wire, when you basically remove the force, the wire will return back to its original length, 19D. Okay, when the tensile force is removed, the wire returns to its original length. Okay, if it's plastic, then it's permanently deformed. But there's and the elastic point is basically after the limit of proportionality. So when you're elastic point, it's not necessary that the object is obeying the Hooke's law or it's a limit of proportionality anymore. It probably has crossed the limit of proportionality by the time it is elastic. Okay, so it says that a bolt is suspended to a tensile force is shown. There is the same tensile force over here and over here. The bolt has a circular cross section. At end x, the diameter is 2d, and end y, the diameter is 0d. What is the ratio of the stress at y over the stress at x? Now, again, as I told you, the better way to do these questions is just making up some constants. Okay, so let's say the value of d is 5. So, what would be the cross section, like the area of the cross section? Because circular, it would be the pi value. Since the radius of this, the diameter is 2d, the radius would just be d. So it would be pi into 5 square, right? Pi into r square. That's the radius over here. I mean, 5 square would be the radius, and if you're multiplying with pi, then you'll get the area on this side. Whereas the area on this side, it will be pi into 2.5 square, because you see d is the diameter, so 0.5d would be the radius. You'll quickly understand that why I'm doing this. Now, what's stress? Stress is basically the force over the area. Let's say the applying force is 10 newtons. Stress at y. The applying force is 10, force divided by the area. The area is pi into 2.5 square. Pi into 2.5 square divided by the same 10 newtons divided by what's the stress at x? It's basically pi into 5 square. Now let's just use a calculator to solve this. 10 over pi into 2.5 square divided by 10 over the pi value into 5 square. What does that give me? That gives me 4. So the answer for this one would be 20d. That is 4. If you're unsure about this, I've assumed the d value to be 5, since the radius of this x part would is essentially d. Diameter is 2d, the radius would be d. So pi into 5 square. On the other side, the diameter is d, so the radius would be 2.5. And hence I've just calculated these and used the forces 10 or equal on both sides to calculate the ratio. Now we'll move on to question number 21.